Guys, welcome back to class. I'm sorry we have to do class online this week, but I'm excited to see you soon. I hope you all had a great spring break. Yeah, and today I don't want the lesson to be too long, so that way you have time to get the homework done, just even within the same amount of class time that we usually have. So I'm gonna get started right away. We are going to be going over law of sines and law of cosines. Hopefully this rings a bell from algebra 2. You have seen this before, but as always in this just class, we take a lot of those concepts you've learned in algebra 2 and go a little deeper with them. So we are going to be looking at law of sines and law of cosines. If you have not already printed this off, my recommendation is go to a printer, print this notes sheet off, and follow along. And if you don't have a printer accessible, just get a notebook and write these notes along in a notebook. And I recommend writing the question down as well, so that way when you go to do the homework and when we have assessments on this, you understand what you're doing, because math isn't something you can just watch and learn. You have to practice as well. So we're going to talk about law of sines, and we're going to solve kind of the different types of triangles we see when we were doing proofs of triangles in geometry and other things. We are going to be using the law of sines to solve different types of triangles. And it's basically, where is it giving me an angle? Where is it giving me a side? So this first one is solving a side angle triangle. So that means I have one side and so then two angles. And so if we see this triangle here, let's say A is 46 degrees. So A is something like this. B is 53 degrees, so it's going to be a little bit bigger. Not quite that big, but that's good. 53 degrees. And then it gives us C. Or sorry, it doesn't give us C. It gives us side C. Which is 56 inches. So this would be my angle C. So my side C is 56 inches. All right, at this point, now we are trying to set this. So when I go to set this up, we would plug it into our equation here. So in this case, it wants us to find side B. So if we wanted to find side B, we would say B divided by the sine of B, which was 63 degrees, is going to be equal to, well, we know what side C is, so let's try C. So C is 56 divided by the sine of C. Well, what we do not know is this C, and what we're trying to find is this B. Okay, so if we want to figure out, in order to find side B, we need to know angle C. Hopefully you can look at this triangle and be like, oh yeah, I can find angle C pretty easily, because all of the angles of a triangle add up to 180. So side C is going to be 180 minus 46 minus 53. Okay, so this should be 81 degrees, I believe. Take a moment, check my work. Yeah, 81 degrees. Okay, so now we can plug that in. Should have brought my calculator here. We got B equals the sine of 63 equals 56, or 56 divided by the sine of 81. So let me try to get that out of here. All right, in order to solve, we just multiply the sine of 63 over to both sides. So we would say B equals the sine of 63 times 56 divided by the sine of 81. When you plug this into your calculator, make sure your calculator is in radians. I'm sorry, degrees. Make sure it's in degrees. Those angles are given to us in degrees. So your calculator needs to be in degrees. So I'm gonna go to my calculator, just double check its mode. Right now it's in radians, so that's a good thing to check. Turned it into degrees. And now I'm gonna plug that in. So I had the sine of 63 times, was it 56 divided by the sine of 81? I think so. Let me double check. Yeah, that's good. So we got 50.52. So B, give me a second. B equals 50. Wow, I forgot it already. 50.52. And this, because my side C was in inches, this is also going to be in inches. Okay. So hopefully something like this you guys remember seeing. We figure out what we want to know in order to plug it in. So in this case, we didn't even use angle A to solve my full equation. So I didn't use angle A in like the sense it is in the equation here. You only need 2 of these fractions in order to solve. So angle A was still really helpful for us. We couldn't have found angle C without knowing angle A, but we didn't use it in the equation, and that's okay, because we were not looking for side A, we were looking for side B. If it asked us to find side A, we would use that first kind of ratio there. All right, so that's kind of one way we can use in order to solve this. You don't even need to draw this diagram every time. If it's helpful to you to draw the diagram, go for it, but it's not necessary. In this case, we'll talk about times where it is. So the next one is asking us to solve is an angle side angle. An angle side angle triangle is like when I have an angle, and then I have my side, and then I have another angle. And that's kind of what happened here. I had an angle, I had another angle, and then I had my remaining side. So in an angle side angle triangle, where A is 50 degrees, C is 33.5, and B is 76 degrees, find the remaining angle and side. So this one's asking us to find everything, so we'll be using all of these equations. Well, for starters here, I know side B, but I don't know angle B. But angle B should hopefully be pretty easy to find, right? Because we know all of the angles of a triangle add up to 180. So we're going to take 180. We're going to subtract the 50. I'm going to subtract the 33.5. And this will give me my equation, or not my equation, but my angle B. I think you should get 96.5. And then at this point, now we can go and solve my other angles. So now that I know angle B, I can now use law of sines. Before I knew angle B, I couldn't use law of sines. So you could say A, because I also need to find side A, divided by the sine of angle A, sine of 50, equals B, my side B was 76, divided by the sine of angle B, which is 96.5. Okay. I'm just going to double check. 180 minus 50. Cool. My math was mathing there. So let's solve this. I need to multiply the sine of 50 to both sides. Once again, these are all in degrees, so just keep your calculator in degrees for this case. I think this entire lesson is in degrees, so you don't have to worry about messing around with changing it. Cool. So A is gonna be 76 times the sine of 50. So 76 times the sine of 50, and that's all going to be divided by the sine of 96.5. So we get 58.5. It actually rounds to 6, so 58.6. It doesn't ask you to round, but if I'm not asking you to round, I just kind of courtesy is around to 2 decimal places. So here I would be rounding to 2 decimal places, but the third decimal place rounded up and the second decimal place was a 9, so it actually rounded to 6. So we get 58.6. Oh, don't know what just happened there. I didn't mean to. I apologize, guys. So that is my angle A. Unfortunately, we are still not done. We found angle B. We found side A. Sorry, that was side A. So side A was in inches this case, so we probably should include inches here. And the last thing we are trying to find is side C. So we still need to find side C. We use my law of sines one more time. We'd say C divided by the sine of C equals, and then we'll just do B divided by the sine of B as the other setup. So B, which was 76, divided by the sine of B, which was 96. Sorry, the sine of 96.5. In order to solve. So why did I choose to put my B's on this case and not my A's on this case? And the only reason is this angle here has no error. My angle B doesn't have error because I solved it. I didn't have to plug something in to solve it. So if we see my angle A here, I rounded to 0.6. It's actually 0.596 ... And so if I use angle A to find angle B, or sorry, to find angle C, I would have some error. It's not going to be a whole lot. It's probably going to be close enough to still get it right. But if you start doing that to continue to solve for new things, then over time that error will increase. So my recommendation is always go back to the original, go back to what you know from the get-go in order to solve these, especially when we're using our trigonometric functions and things of that nature, because that's going to be the most accurate. So that's why we chose to use B over sine B instead of just using A over sine A. Okay, so same process. Multiply that sine of 3.5 to both sides. And we will be getting my answer here. So we'll throw it in. We got 76. 76 times the sine of 33.5 divided by the sine of 96.5. And we get a whopping 42.22. So 42.22. And once again, this is in inches. So now I'm done. I've solved all three things it's asking me to do. It was trying to have me solve the missing side, the missing two sides, and the one missing angle. So we have done that. So we are done. So hopefully seeing this, you guys are like, okay, I kind of remember doing that, and how we can use law of sines to solve different things for us. So that is in our general cases. So that works for a side angle triangle. It works for an angle side angle triangle. Yeah, it does not work for a side triangle. And I'll just explain why. If I have a side triangle, I don't have any angles. So if I went to solve this, I would be able to plug in my A. So let's say A was 5, but I don't know what sine A is. And I could plug in B, let's say it's 4, but I don't know what sine B is. And I could plug in C, but I don't know what the sine of C is. And so with that, I don't have any of the angles, because solving for using law of sines requires a ratio. You need to have at least one angle to solve it. So we can't do this. So we had side angle. That is what happens when I have two angles. Oh, this would also work for a side angle. side. So this does work. Side angle side is good. SAS. This would work for that too. Where I have an angle switch between two sides. So it works anytime I have two angles, whether it's an angle side angle or a double angle and then a side, or a side and then a double angle. We basically like a side and then a double angle is the same thing as a double angle and then a side because you just could read it backwards basically. It works for a side angle side. One of these, so these are all proofs. Remember, we could prove that triangles were congruent by using these three or these four laws: the side, angle, side, angle, side, and side, angle. So we could use those four laws to prove that something was congruent, that a triangle is congruent. One of the equations that we like to think works for congruency, proving congruency, is side, angle. So this one, if we were trying to prove that something is congruent, it does not actually prove. So, and we'll talk about why in a second. So it does not prove congruency. It never proved congruency back in geometry. So, but why is that? We'll talk about this case in particular is the ambiguous case. And so basically we can have multiple things happening when I have a side angle. So we'll talk about different cases. So the side angle it's giving us here is it's giving me side A, side B, and angle C, I believe, in all of these cases is what it's giving us. So basically what we can have happen is it's not giving me angle C, it's giving me angle A. It's giving me angle A, side B, and side A. That makes more sense. So it can give me this angle here, which is fine. But if it's an acute angle, then A is going to be a shorter side, right? Because the length of a side is comparable to the length of my angle. So if my height of my triangle is larger than the length of A, then my triangle will not exist because that A will not make it down to point B, basically. So if I get something like this where the length of my, and it doesn't give us height, so it's a little harder to test. So we'll do different ways of testing it. But yeah, if it doesn't equal, then I can't really do too much with it. Or if it's smaller. My next, so that's one of the ones. If it's acute, if A is acute, if we look down instead of looking to the right, if A is acute here, and it equals the height of my triangle, then we will get one triangle. So we can see that happening here. So sometimes when A is acute, I get no triangles. Sometimes when A is acute, I get one triangle. So this is why we have to do some testing that we'll talk about in a minute. Sometimes when B is obtuse, A is obtuse, so in this case we see A is an obtuse angle. If A is equal to B, or if A is less than B in this case, so this is my side B, my side A. So basically, if A is obtuse, A is going to be the largest angle because you can only have one obtuse angle in a triangle. So if A is obtuse, the angle A is obtuse, then angle or side A must be the longest. And if side A is not the longest side, even if it's equal to another side, then it's not a triangle. But if A is obtuse and A is greater than, like I said, if A is the longest side, it's greater than B, then we got a triangle. We just have one triangle. And then these are next two examples are, once again, if A is an acute angle, and we have a couple different options here. If A is an acute angle and A my side A is greater than my side B, then we get one triangle that exists. So if A is acute, but my side A is greater than my side B, then we get one triangle. And we'll talk about how that happens. The last one is kind of one of the trickiest ones to understand, I would say. If once again A is acute. So if A is acute and A is greater than my height, but less than my side B, then we have something where two triangles can exist. So I think it's easier if I split the triangles. So basically, this is what I'm given for starters, right? I'm going to take it off. This is what I'm given for starters. Let's say A, or that B should be a dotted line. 1 second. Let me change that. Because remember, B is a length I do not know. So we're trying to figure out B. So let's say if A is roughly this size. A could be this size here, but that length, I could just rotate it, which I don't have a way to rotate on this iPad, but I could just rotate it and it's the same length here. Okay. So if this is the same length as this, we can see, okay, I can make two different triangles. One where B is a acute angle and the other where B is an obtuse angle. So those are the kind of two options we have happening there. And like I said, height isn't usually given to us. It is something you can always solve for. But we will talk about how can I use the law of sines to solve something like this. So, given a triangle, and for this one, we will practice drawing it because I think it's helpful. So kind of like how we just drew all of those last triangles. Let's go ahead and do that. So we're gonna draw our triangle. Keep in mind, in this case, A is acute. So A is 43. Side A is 81. And B is 62. It wants me to find all the remaining sides. Okay. So this is A, that's B, this is angle C, and this is side C. Okay, so now we have our triangle. So we are in a good place to try the next thing. So first things we're gonna try to do is see if I cannot simplify, or actually, sorry, theoretically, law of sines should work right now, right? Because I can find side A or side B using law of sines. We would say the sine, or sorry, A over the sine of angle A equals B over the sine of angle B. All right. So theoretically, I should be able to solve right off the bat here. Well, let's real quick look at this, compare it to that diagram we were looking for. So first off, A is acute. So we'll look at the examples where A is acute. Second off, side A is greater than side B. Okay, so if A is acute and side A is greater than side B. Let's look at it. So here we have A is acute. These two ones are A is acute, but these are comparing A to the height on the left side. So this is what I'm trying to show you. So these are A is acute, but it's comparing A to the height. It's comparing A to the height. Well, I don't know the height of my triangle. So let's compare A to B. So these are also A is acute. So maybe I'll write that on the top so you know. You can kind of see it in the diagram, but it's helpful to write down. So this is where side A is greater than side B. That's what we have here. Side A is greater than side B. Okay, this is good news because when I have side A is greater than side B, I just have one triangle existing. So I can go through and solve this, and I'm just going to have one triangle exist. And this is kind of what's telling me right off the bat, which is helpful. So I want to give you, I would like for you to try to pause this video and solve for side B on your own, just to get some practice doing it on your own. And then you can press play again when you finish solving for side B. So you have the equation here, so you can just go ahead and solve. And if you want to challenge yourself, pause the video and solve for not just side B, solve for side C and angle C as well. Okay, hopefully you guys did that. Obviously can't make you. So we're trying to find side B. This one is actually a little bit more difficult to find sine B because finding angle B, we just had to like multiply by the sine of B and then we would have it. Finding an angle B is a little harder. First off, that angle B is in the denominator. I cannot solve for anything if it's in the denominator, so I'm going to have to multiply by the sine of B by both sides. Okay, so we get the sine of B times 81 over the sine of 43 equals 62. Give us a little bit of space here. Okay, if I want to get rid, I just want B by itself. So I really want to leave sine B. I want to get rid of this whole fraction. The way to get rid of a fraction is multiply by its reciprocal. You could have divided and multiplied, just adding a step. So multiply by its reciprocal to both sides. 3 over 81. Okay, awesome. This multiplies through. We get sine of B. Oopsies. And you need to use your calculator to do this. 62 times the sine of 43 divided by 81. We get 0.52. Does that sound right? Yeah. Cool. 0.52. But I'm not quite done yet because I need to find B. It says the sine of B is 0.52, but if I want to find B, we have to get rid of sine using inverse sine. So take inverse sine of both sides. That will give us B. So we take the inverse sine, press second sine of 0.52. And we get 31.33 degrees for my side, my angle B. So we get B equals, sorry, I just forgot it already. 31.33. Yeah, 31.33 degrees is my angle B. This is good news because now I have my angle B. I am capable of solving for my angle C because now I have two angles. I can find my third just knowing that 180 minus 43 minus 31.33 is going to give me whatever my third angle is, which in this case is angle C. So we can plug that in. Sorry, I feel like I'm moving kind of quickly. If you get confused, you can always pause. And I understand this math on the right side is a little bit trickier, but it is stuff we have seen before. You can't solve for something if it's in the denominator, so you need to multiply it over. If you have a fraction, you got to get rid of, you got to multiply by its reciprocal, which is what we're doing here. And then if you have a sine of B, in order to get rid of the sine, you have to take inverse sine. So hopefully these things are ringing a bell. Okay, so then we get angle B, which is this. We can find angle C by just subtracting it from 180. So 180 minus 43 minus 31.33. We get 105.67 for angle C. So C is our obtuse angle here. Cool. So last thing we're trying to do is find side C. So we would say, I would use A because those were the points that were given to me, right? Was A, side A and angle A. So we would say A divided by the sine of A, the sine of 81, equals C, my side C I do not know, divided by the sine of angle C. My angle C was 105.767. So in this case, just like we were doing in those previous problems, multiply the sine of 105.67 to both sides. And we will get C. So C is the sine of 105.67 times 43 divided by the sine of 81. All right, we get 41.92. 41.92 is going to be my side C. So then lastly, C is 41.92. Wow, I'm all over the place. 41.92. And it did not give us units here, so it's not in inches. We just don't quite know what it's in. And those are all it's asking me to solve for here. So we have solved for everything. All right, so I am going to pause this recording and start a new one. My goal is to not get these to be too long, just so it's easier for me to post them. So I will pop back on here in a new video in a second. So see you in a bit.